Welcome to the deep dive. We're here to take all those sources flying around and, really pull out the key insights for you so you can get informed without getting totally overwhelmed. Today, we're diving into a world that's, well, let's be honest, buzzing with both massive hype and some genuinely cool innovation. Web3. Specifically, we want to look at its practical, sort of real-world uses in autonomous systems. We've got quite a mix of sources to help us navigate this. There's an LCX report looking at why big companies are hesitant about Web3. Then a really detailed paper from ArcSpiv about something called DeFeed.
Right, that one's focused on secure data for connected autonomous vehicles.
Exactly. And then we've got a frankly quite lively Reddit discussion digging into actual Web3 use cases people are seeing. And finally, another ArcSIF paper that explores this bigger idea of trustworthy, decentralized autonomous machines. So, quite a bit to chew on.
Definitely a fascinating set of perspectives.
So, our mission today really is to cut through all the noise. You hear so much about Web3, NFTs, crypto. We want to unpack how it's actually moving beyond those headlines, beyond the hype, into creating genuinely secure, efficient, and maybe even transformative solutions, especially in this demanding area of autonomous vehicles and smart machines.
Yeah, moving from speculation to actual utility.
Get ready for, hopefully, some insightful connections and maybe a few aha moments you weren't quite expecting. Okay, so let's start unpacking this. Web3 stuff is developing fast. I mean, really fast. This LCX report we mentioned, it projects the Web3 market could grow by what? Almost 45% between 2022 and 2030. That's huge growth.
It is, but what's really striking is how differently people see it. It's incredibly polarized. Like you said, you've got some businesses, innovators looking at it thinking, wow, this is disruptive, this could change everything, new business models, new revenue.
Right, the next big thing.
But then others, maybe more traditional players, see it as just a nuance, something they sort of have to deal with, but not core. And of course, the blockchain platforms themselves, the layer ones like Ethereum, they sometimes act like it's the answer to, well, everything.
Which maybe it isn't always.
Probably not. And then you get the media sometimes jumping in and calling it the greatest fad of all time. It's a real mix.
It really sounds like a mixed bag. So for you listening right now, what does this big perception gap actually mean for, say, large businesses trying to figure this out? Because the report says, even with all this potential for growth, there are some serious roadblocks to getting Web3 adopted widely, commercially, at scale. It's not just about the tech itself, is it?
Oh, not at all. It's much more than that. It's about integration. It's about understanding, overcoming inertia, really. Think about it. Many big companies are built on centralized control. Moving to something decentralized, trustless, maybe even permissionless. That's a huge mental shift.
It's a cultural change almost.
Exactly. You're rethinking operations, security, legal stuff, everything. So there's this real divide between companies that are just curious and those actually managing to implement it properly.
That makes a lot of sense. Okay, so let's get to the core of many of these applications' smart contracts. Most people, if they've heard of them, it's probably, NFTs or maybe DeFi. But what are they, fundamentally? How do they actually change how we build things online?
Right. So at their simplest, smart contracts are self-executing agreements. Think of it like code, code that lives on a blockchain. And it's programmed to automatically do something when certain conditions are met. No middleman needed.
Okay, so it just runs itself.
Precisely. And that changes things because they have these unique features. First, immutability. Once you deploy that code, you can't change it.
Can't change it at all.
Nope. Not the deployed version. Then there's trustless execution. It runs exactly as written. You don't need to trust a third party. And high availability, because it's on this distributed network, we're seeing them power huge things already. Decentralized finance, DeFi you mentioned. Platforms like Uniswap trade billions using them. And NFTs on OpenSea, that's all smart contracts too. They're like the programmable plumbing of Web3.
Okay, that immutability, not being able to change it, that sounds fantastic for security. Makes sense. You deploy it, you know it won't be tampered with. But doesn't that also make things really rigid? What happens if the real world changes? Or worse, what if you find a bug after you've deployed it? That seems like a huge problem.
You've hit the nail on the head. That's the paradox. Immutability gives you integrity, which is great. But it also means, by default, smart contracts aren't like normal software you can just patch or update. If you find a bug or a vulnerability, fixing it is tough. You usually have to deploy a whole new contract.
Which sounds expensive and complicated.
It can be costly, yes, and it can split your users between the old contract and the new one. So this whole area of designing upgradable smart contracts, finding ways around that rigidity, is a massive focus for researchers and developers. It's this constant tension, security versus flexibility.
Okay, and then there's the other big thing people hear about, cost. Every little interaction on a blockchain like Ethereum costs gas. For someone used to just browsing the web for free, paying for every click or action, that sounds potentially really expensive. What is gas exactly, and how much does it impact things?
You're right, it's a totally different model from Web 2. Gas is basically the fee you pay for computation on the network. Think of it like paying for the processing power needed to run your transaction or execute that smart contract function. It's paid in the network's currency, like Ether for Ethereum, and it's crucial. It stops people from just spamming the network with endless tasks because every operation has a cost.
So it prevents denial of service attacks, things like that.
Exactly. Users set a gas limit, the max they'll pay, and a gas price, which is like a bid for how quickly they want their transaction included.
Yeah.
Miners, the ones processing transactions, prioritize the higher bids.
Okay.
But the impact, yeah, these fees can get really high, especially when lots of people are trying to use the network at once. And that DeFeed paper we'll talk about, it specifically notes that sometimes protocols have to make compromises. They might sacrifice some decentralization or some trustlessness just to bring down those gas costs for their users, which, kind of undermines the whole point of Web3 sometimes.
Right, it forces trade-offs. So these challenges connecting contracts, the cost of doing things on-chain, this leads us perfectly into DeFeed. This solution from one of the ArcSIF papers seems designed to tackle a specific bottleneck, the cross-contract data feed or CCDF problem. So first listening, what is the CCDF problem and why is fixing it so important, especially for something like connected autonomous vehicles, CAVs?
Okay, the CCDF problem is basically this. By default, smart contracts live in their own little silos. One contract can't just easily reach over and read data directly from another contract's storage. Imagine two apps on your phone, say your fitness tracker and your map app. They can't just share complex real-time data directly between themselves without going through some central server or a pre-built integration.
Right. Makes sense. They're separate.
Smart contracts are like that, but even more siloed by design for security. Now think about CAVs, connected autonomous vehicles. They need to share data constantly. Traffic updates, road hazards, maybe what the car next to them is doing. And they need to do it securely, efficiently, and crucially without relying on one central company controlling all that data flow. That central point is a vulnerability.
A single point of failure or control.
Exactly. DeFeed is built to solve this. It lets smart contracts get info from others almost like a single click, simplifying things massively, cutting out complex steps. And this is key, using special functions to save on those gas fees we talked about, is trying to build that missing communication layer for decentralized systems like CAVs.
Okay, a single click sounds great, but how does it actually work under the hood? Can you give us the simplified version without drowning us in code details?
Sure, let's simplify. Think of DeFeed having a few main players, like actors in a play. You've got a data owner contract.
Yeah.
That could be one CAV, say, broadcasting its location. Then you have a requester contract, maybe another CAV that needs that location data.
Okay, the giver and the asker.
Right. Connecting them is the main data feed center contract. That's like the central switchboard, handling the logic. Then there's a data feed managing contract, which acts like a smart proxy or gatekeeper. And overseeing that proxy is a committee, a group, ensuring the system's integrity.
Committee, okay.
So the flow is roughly, data owner registers with the center, requester asks the proxy for data, proxy passes it to the center asks the owner for the specific data, gets it, and sends it back to the requester via the proxy.
Seems like a few hops.
It is, but it's designed to be a secure and standardized channel, much simpler than trying to build custom connections between every single contract pair.
Got it. But with all those interactions, especially for something critical like autonomous vehicles, how do they keep it secure and efficient? What stops someone messing with it?
Security is absolutely baked in. They use several tricks. For example, there's a function, sort of like a digital bouncer, called access only. It checks if the contract asking for data is actually authorized to get it.
Prevents snooping.
Exactly. They also use cryptographic hashing, like giving each function call a unique tamper-proof fingerprint using something called KEKAK 256. This makes sure that when a contract calls a function, it gets exactly the function it intended, no sneaky substitutions. And that committee managing the proxy, they use a multi-signature system. Think of it like needing several different keys turned at the same time to open a bank vault.
So no single person or entity can control it.
Precisely. It relies on a secure way of sharing control, often called a T, secret sharing scheme, significantly boosting trust and making it harder to corrupt.
Okay, that makes sense. Now, those gas-saving functions you mentioned earlier, that sounded like a potential game changer given how high gas fees can be. What did the researchers actually find? How much difference do they make?
Yeah, this is where DeFeed gets really practical and shows its value. They tested it on an Ethereum test network, Sepolia, and measured the gas costs. The results were pretty impressive. First, there's a pool function. Instead of processing data requests one by one, which is inefficient, this lets DeFeed bundle them up and handle multiple requests simultaneously.
Ah, batch processing.
Kind of, yeah. And the savings were significant. For example, handling 100 requests together cut gas costs by 36% compared to doing them individually. And the more requests you pool, the bigger the saving. That's huge for a busy network of CAVs.
Okay, 36% is definitely noticeable. What else?
Then there's the cache function. This lets DeFeed remember the results of successful data requests. So the first time a contract asks for a specific piece of data, using the cache, it might cost a bit more, say around $1.55 in their tests.
Right, setting up the cache.
But every subsequent time, another contract asks for that exact same data. It only costs about $0.42. Much cheaper, because it's just retrieving the stored result. Great for frequently needed, fairly static data.
Big savings over time.
Definitely optimizes long-term costs. Then there's a subscribe function. If a contract needs continuous updates from another think real-time traffic data, it can subscribe for about $0.35. That's way cheaper than making repeated individual requests, which cost around $1 each in their test.
Okay, that's vital for real-time stuff.
Absolutely. And finally, even updating the core logic, the main data feed center contract itself, that was also designed to be relatively cheap, costing about 23 cents.
Wow, so the takeaway isn't just, oh, it saves a bit of money. It's more like these efficiencies make the whole concept of truly decentralized interacting autonomous systems actually viable on a public blockchain.
Exactly. It tackles that core communication and cost problem head on, moving it from a theoretical possibility towards something you could realistically deploy at scale. That's a significant step.
It really bridges the gap. Okay, so that's a deep dive specifically into CAVs and how DeFeed helps them. But for you listening, what does this broader Web3 stuff mean beyond just self-driving cars? That Reddit discussion we mentioned had a ton of other practical examples popping up, things that might affect everyday life more directly.
Yeah, it did. And it's important to look beyond the, speculative assets or abstract concepts. Web3 is starting to offer tangible solutions for everyday problems, like simple peer-to-peer networks. They cut out the middleman, right? Makes transactions, file sharing, whatever, more direct.
Less friction, maybe lower fees.
Potentially. And NFTs, everyone thinks digital art, maybe collectibles. But the discussion highlighted using them for things like housing deeds, proof of insurance, even birth certificates.
Wait, like my house deed as an NFT.
The proof of the deed, yeah. Verifiable ownership recorded on a blockchain. It allows for scalable, hard-to-forge verification without needing to rely solely on a central government database or registry for everything.
That's a fundamental shift in how we think about proving ownership. I also saw points on Reddit about just paying for things online and owning digital stuff.
Absolutely. Imagine just connecting your crypto wallet to an online store to pay directly. Maybe bypass some credit card fees. Maybe have more control over your payment data.
Okay, simpler checkout.
And think about digital goods, books, movies, music. Right now, you mostly license them. What if you could truly own the digital file, represented by an NFT perhaps? Own it in a way that allows you to resell it on a secondary market. And this is the clever bit. The original creator automatically gets a royalty payment via the smart contract every time it's resold.
Ah, so creators keep benefiting.
Exactly. And this connects to the idea of a social graph, basically, your network of online connections and interactions. In Web3, the idea is you own that graph, not the platform like Facebook or YouTube. This could give creators more direct power, more ways to monetize their audience without being totally reliant on the platform's rules and algorithms.
It sounds like Web3 is trying to fix some really basic problems or power imbalances in how the current internet works. Rewriting the rules, almost.
That's a good way to put it. We're seeing people build solutions for decentralized hosting and storage, too. Projects like Power Ecosystem mentioned in the thread, aiming to be a Web3 alternative to cloud giants like Amazon Web Services, more user control over where data lives.
Taking on AWS, that's ambitious.
It is. And content copyright. There are tools emerging, like Shark was mentioned, that let creators register copyright claims on the blockchain and potentially automate enforcement, maybe without needing lawyers for every little thing.
Streamlining that whole process.
Right. Even monetizing your own personal data, something people talk about a lot. New protocols are trying to give you privacy and control, letting you choose to share certain data securely and maybe get paid for it within decentralized finance systems.
So you control your data, you profit from it if you choose.
That's the promise. And many people on Reddit also pointed out things like Web3 offering a built-in global payment system for online businesses, kind of like cash for the internet, and better user authentication logging in without storing passwords centrally where they can be hacked.
And gaming often comes up too.
Yeah, gaming is seen by many as a potential Trojan horse for mass adoption. Once the games themselves get really good and seamlessly integrate Web3 ownership or earning mechanics, that could bring millions of people in.
That's a huge range of applications, way beyond just finance. Which leads us nicely to this even broader concept, Decentralized Autonomous Machines, or DAMs. This came up in the other Archive paper. Now, we're not just talking about vehicles, are we? This is about any machine potentially becoming its own independent agent.
Exactly. If we zoom out to the biggest picture, dams are this potentially transformative idea. They combine artificial intelligence, blockchain, and the Internet of Things IoT devices to create machines that are essentially self-governing economic agents.
Self-governing economic agents,
Yeah.
okay.
The key difference from DAOs, decentralized autonomous organizations, which are mostly about digital communities making decisions, is that dams operate in the physical world.
Right, they interact with reality.
Yes. They can manage not just digital assets, but real-world assets. Think of a smart vending machine that monitors its own stock, uses crypto to autonomously order more drinks when it's running low, pays the delivery drone, maybe even schedules its own maintenance checks.
Wow. Or that autonomous taxi fleet example you gave earlier.
Precisely. A fleet that manages bookings, collects fares directly into its own wallet, optimizes charging schedules, maybe even pays for repairs autonomously, all governed by code and AI, not a central dispatch company.
So these are machines that can basically earn, spend, and maintain themselves. That vision sounds incredibly efficient, maybe even more democratic in some ways.
That's the potential upside. It represents a shift from economic models based on trusting institutions to models based on trusting code and verifiable data trustless models. This can cut out middlemen, reduce costs, increase transparency, and remove those single points of failure we talked about. It could enable things like fractional ownership, too.
Fractional ownership.
Yeah, imagine you and others shipping in to collectively own an autonomous delivery drone or a high-tech farming machine. The dam operates, generates revenue, and distributes profits automatically, according to the smart contract rules. It democratizes access to productive assets.
Opens up new investment opportunities.
Potentially. And AI is critical here. It lets the dam sense its environment, interpret data like analyzing sensor readings to predict when it needs maintenance. It could even use natural language processing to coordinate with human service providers if needed. And of course, operate itself to earn revenue.
It sounds powerful. But what about security, privacy? How do we make sure these autonomous machines managing real assets and making real decisions operate safely and don't leak sensitive data?
That's a huge and critical question, and the paper digs into it. Security and privacy are paramount. Dams need sophisticated tools. One key technology mentioned is zero-knowledge proofs, or ZKPs. These are really clever cryptographic techniques.
Zero knowledge. Sounds mysterious.
It basically allows one party, say, the dam, to prove to another party that a statement is true, like, I performed this maintenance check correctly, without revealing any of the underlying sensitive data used to make that statement.
Like proving you're over 18 without showing your actual birth date.
Exactly like that. It's incredibly powerful for validating computations or sensor readings that might happen off the main blockchain without compromising privacy.
Okay, ZKPs for privacy. What else?
Another important piece is trusted execution environments, or TEEs. Think of these as secure vaults or enclaves, built directly into the machine's processor chip. Critical computations and sensitive data can be processed inside this TEE, isolated from the rest of the system, even from the main operating system.
So even if the machine gets hacked somehow?
The idea is that the stuff inside the TEE remains protected. This is vital for ensuring the integrity of the dam's core operations and keeping its private keys or sensitive operational data safe, especially when it's interacting with valuable physical assets.
Wow. Okay, what a journey through Web3 today. We've really covered a lot of ground, from the hype and the real barriers holding back big companies through the nuts and bolts of smart contracts and their challenges.
Right, like immutability and gas cost.
Then into specific solutions like DeFeed, making connected vehicles actually work better together in a decentralized way.
Showing real practical improvements in efficiency and cost.
And finally, zooming out to this potentially massive future of decentralized autonomous machines interacting with the real world.
It definitely feels like the landscape is shifting, moving towards systems that value transparency, decentralization, and security built into the code, rather than just relying on intermediaries or central authorities.
Building trust in the system itself, not just the players within it.
Exactly. Trust in code and consensus.
So, as you, our listener, go about your day, here's something to maybe chew on. In a future that might not be that far away, how could these kinds of advancements fundamentally change how you interact with technology every day, even with physical things? Will we reach a point where we find ourselves trusting these algorithms, these decentralized networks, maybe even more implicitly than we trust some of the traditional institutions we rely on today? Definitely something to mull over.
A provocative thought indeed.
All right, that's all the time we have for this deep dive. We really hope you picked up some surprising facts, some valuable insights. Until next time, keep exploring, keep learning, and yeah, keep asking those big questions.